Today we're going to cover the operation of wastewater lift stations. Every once in a while, you'll see the chapter and section from one of the manuals superimposed on the screen, like this. 8.1 means refer to Chapter 8, Section 1. Once again, we'll be working from these manuals, Operation and Maintenance of Wastewater Collection Systems. And we'll have our friend Gonzo with us. Gonzo.
La la la, la la la, la la.
There are only two ways of doing things. One is the right way, the other is the Gonzo way.
Here's the address and phone number where you can get the manuals and this series of training videos. You'll also find this information on the cover of this video.
Now let's talk about the efficient operation of a wastewater lift station.
Lift stations and pump stations are used to lift or raise wastewater or stormwater from a lower elevation to a higher one. Lifting of the wastewater is accomplished by centrifugal pumps or air-operated pneumatic ejectors.
A lift station such as this one pumps a relatively short distance into a gravity sewer. A pump station, on the other hand, pumps a relatively long distance into a force main.
It's the responsibility of the operating agency to ensure the operation of these stations.
This responsibility for the lift stations includes preventing failures in the operation of the station which would cause flooding in neighboring homes, businesses, and streets.
Responsible design includes no facilities for bypassing wastewater to rivers, streams, lakes, or drainage courses.
During an emergency, portable emergency equipment must be used to pump the wastewater into a functioning downstream section of the collection system and not into the environment. Lift stations are located throughout a community. Their appearance is paramount. We as professionals must be very aware of their odors, noise, and appearance.
If you receive a complaint about a lift station, be sure to tell the public what has been done or will be done to correct the complaint. If you don't know, find out and call the person back. Never leave a complaint unanswered.
Not all lift stations require the same number of personnel for each station visit. Your agency should determine this number by the type of lift station, the procedures, and the hazards.
Many wastewater lift stations are considered by state OSHA agencies to be confined spaces and others to be enclosed spaces.
Your agency should survey each lift station to determine which station or area of a station should be considered or classified as a confined space.
Always follow the correct entry procedures when entering these types of lift stations. Safety precautions regarding the potential presence of hazardous gases apply not only in the wet well, but in the dry well area of the station too.
When it's necessary, always take the time to pick up the additional required crew member.
Because there are many factors involved, it would be impossible to suggest how often to visit and inspect your lift stations.
Frequency of lift station visits depends on the number of stations in the community, the type of wastewater being conveyed, the potential damage resulting from flooding the station, the condition of equipment, and the alarm telemetry system.
The design of the facility and the equipment installed are also factors.
How well you follow your preventative maintenance program will also determine the need and frequency of visits.
Of course, the number of available employees also plays a part in the number of visits to the facility.
Many operating agencies make daily visits to their stations because that's what they've always done and because that's what some other communities do.
The truth is, the experience of other agencies is not the best experience to base your lift station visits on. So where do you get your answers? Your answer is in your own records.
How many station failures are found each day? What functions were performed at each lift station that kept the station operating? How many actual hours of work are performed during each visit? What is the critical period of time if the station does fail? You'll need the records on the number of station failures, failure of level sensing or other control equipment, flooded wet wells, plugged pump impellers or pipelines, overheated and tripped out motor thermals, sump pump off and sumps or dry wells flooded, air pump, stuck or blocked check valve, pump control systems not functioning, failure of lift station telemetry system, ventilation fans not working. What is the critical period of time if the station does fail? When this critical time is determined, it tells the station crew how long they have to respond to an alarm condition before backup flooding or overflow will occur.
When I want to alert people to an alarm, I just do... Works for me.
Remember, if your pump station's downtime is under an hour, we have a serious problem. Certain decisions must be made, either to install larger pumps, or if money and space are available, install a larger wet pit.
Another good idea is an emergency response plan for each lift station. If power failures are a problem, an emergency generator should be installed to operate the station during power failures. Other solutions to power failure include portable generators, 2 sources of utility power, or engine drive pump.
Lift stations can be operated automatically, and if designed and maintained properly, do not require daily visits. The truth is, daily visits cause some operators to let a station get by on a quick glance because they were there yesterday and will be back tomorrow.
Stations that are visited daily may be dirtier and more in need of maintenance than stations visited less frequently. Important maintenance items are often delayed until tomorrow, which sometimes doesn't come for a month.
It's okay. We'll check them tomorrow.
If the lift station requires a daily inspection, the station book should have a daily task checkoff sheet indicating the task to be performed and a space for the initials of the operator who performed the task.
A very important aspect, regardless of the frequency of visits, is the fact that operating and maintenance operators responsible for lift stations must be provided the time and training to adequately perform each task.
Occasionally, supervisors must inspect the station after a crew visit to make sure that the tasks were performed and not merely signed off.
Once procedures and objectives have established that specified tasks must be done on a routine frequency, whether daily, weekly, monthly, quarterly, or annually, the operators responsible for the lift station must accept the responsibility and be sure the tasks are completed when scheduled, so the operation of a lift station will be as reliable as possible. It's your responsibility as a professional.
Analysis of the records can indicate if adjustments in the frequency of the tasks are necessary.
Small communities with 1 or 2 lift stations may find it more economical to visit stations twice daily rather than to install and maintain a telemetry system. However, here's maybe a better approach. It might be good to use a phone line and an auto dialer connected to a beeper which is able to signal an alarm condition.
When the operating agency has more than 15 stations to operate and maintain, then the time consumed for the single daily visit becomes very large and quite expensive.
If station visits can be reduced to a weekly or monthly basis, the savings are substantial.
Let's review briefly. The purpose of this video is not to convince every operating agency to extend lift station visit frequencies. It's just not applicable to every station. Confidence may be the crucial concern. Many people have little confidence in their lift station's equipment and programs, and they don't believe that a station can operate for a week, let alone a month.
We may ask ourselves the question, why are some wastewater lift stations visited daily across the country? The answer may be that the operators for the lift station had their previous experience at a wastewater treatment facility. They had rules and regulations that required a daily check.
Fortunately, most small lift stations are not as complex and can be designed and maintained in a manner that allows the station to perform its functions automatically and without daily visits.
The following are the requirements that must be met to permit limited visits to lift stations of once a week to once a month. Equipment lubrication reservoirs must be large enough to hold lubricant supplies to meet the needs between visits to the station. And telemetry of the station is also required.
These guys with their little wimpy grease guns, when I lubricate, I need a lot of lubrication.
Most lift stations constructed today have a telemetry system that monitors for a high water alarm.
Usually other items may be sensed and alarmed on the same high water alarm signal. For example, water level in sump pump pit of dry well, power failure, air compressor failure, telemetry failure, pump motor failure, lift pump check valves, inside temperature, and alarms indicating break-in.
On a lift station with auxiliary equipment, the following items may be telemetered: water supply pressure, chlorine leaks, low chlorine pressure, high temperature of motors and engines, and standby generator operation.
With the recent advances in solid-state electronic equipment, telemetered monitoring and supervisory control systems have become much more commonplace in collection systems.
These systems utilize an electronic interface device that transmits alarms and monitoring information over radio signals and telephone lines.
Information is received at a central location. This could be a dispatch center in the community that's always in service. Examples are the public safety office, or the utility company's dispatcher, if there is one, or a telemetry system that activates a pager directly to a standby person for immediate response.
A simple system may be nothing more than an annunciator board that signals the type of alarm and the station.
More sophisticated microcomputers are now frequently used. They perform logging functions of such information as date, time, and nature of alarm.
In some systems, the computer automatically pulls the status of the lift stations in a predetermined sequence.
If an alarm occurs, the computer can be programmed to automatically dial a pre-programmed number to a collection system operator and relay a message over the phone. SCADA is used for monitoring lift station alarms, flow monitoring, rainfall information, and river quality monitoring information.
Analog or digital inputs are fed into a remote terminal unit, which is in fact a microprocessor located inside of the lift station.
Although this is a fairly sophisticated system, the complexity is determined by the size and needs of the agency.
Alarm?
Alarm! No, Gonzo's not here right now. I'm not sure when he'll be back. Uh-huh. You're welcome.
Generally, the graphic information available to the dispatcher when a lift station alarm occurs includes lift station number, flow meter number, time, date, alarm acknowledge indicator, power failure, transmission line failure, station power failure, standby generator running, high wet well, high dry well, pump 1 failure or pump 2 failure, and site security.
Additional information that can be pulled up on the station are critical utility phone numbers, who's on standby, daily log entries, comments that may have been put in there by an operator earlier in the week. He may have had a problem. Operator response and action taken by the dispatcher.
Virtually any type of alarm telemetry system improves the options available to the collection system operator when assigning personnel and equipment resources, particularly during emergency situations.
Events such as rain, snow, blizzards, wind, hurricane, tornadoes, power outages can all place a great strain on any wastewater collection system.
So what are we saying? The only time a lift station should be visited is during a dignitary tour or when management is doing an inspection? No. What we've attempted to convey is a very important fact. Wastewater lift stations can be capable of operating automatically, but of course operators periodically must visit the lift station to see that it's operating as expected and to perform scheduled preventive maintenance.
There are two other types of station visits that are significant. One, to perform scheduled routine preventive maintenance upon the equipment in the station, and two, to respond to a lift station alarm or emergency condition. The purpose of this visit is to restore the station to operation.
Proper maintenance and the right frequency schedule is the key to keeping emergency responses to a minimum.
Proper maintenance will allow these stations to operate automatically for long time periods.
Frequency of visits depend on equipment and conditions. You may have a station that will overflow in 15 minutes and the quickest response time may be 30 minutes. you may have to man that station continually.
Every lift station should have a sign-in log. The larger the operating agency, the more important it is. This practice helps track down changes in station operation, such as pumps turned off, control system changes, and station doors or gates left unlocked. It provides a method for reaching the appropriate person when corrective instructions need to be issued.
Sign-in log sheet produces a higher reliability, as a person is going to feel more responsible as their name will be signed in the logbook.
No crew wants a station failure a few minutes after their departure because they had neglected something.
The station sign-in book is kept on a shelf or in a cabinet with the station book. As an operator, it is very important that if you're the last person to sign in the log sheet, that you make sure that the log sheet is returned to headquarters and put in the permanent record so that any future problems that come up, people can look back.
New sign-in sheets are kept in the station as part of the preventive maintenance schedule. These sheets should be numbered in advance to help flag missing pages. In some agencies, the logbooks are maintained at the station for an entire year. The problem with this approach is that the agency's management may not see these logs, and as a result, may not be kept informed of station problems and conditions.
The station book is a loose leaf binder so that information can be easily kept up to date.
So this one goes here, and if this goes here, if I could, that one there.
The lift station book should contain the following information: station identification number, map showing important facilities, station description, safety instructions, equipment data sheets, emergency conditions and the action to be taken when an emergency occurs, and the station preventive maintenance schedule. The critical time until homes or streets are flooded must be included.
If an auxiliary power generator is not standard equipment at the station, the procedures for obtaining a generator should be located in the station book.
Also included are procedures to electrically isolate the lift station and to connect a portable generator.
Not every agency can afford to use the kind of telemetry systems that specify the item of equipment and the problem in a remote lift station. However, many agencies use alarm systems simply to indicate that the lift station needs to be visited.
The signal is received at a facility that is staffed 24 hours a day. In many cities, this is the local police department or emergency dispatch center. When the station has a failure, the alarm is transmitted, usually through leased phone lines, to a control panel at the center. An indicator light for the particular station goes on when a problem develops, and a horn or some other type of noisy alarm may also be activated. When trouble is indicated by phone or radio, the dispatcher notifies the operator on duty of the station identification number. On an appropriate log sheet, the dispatcher must record the time and identification number of the station and the time and the name of the operator notified.
Usually during off-duty hours, the operator notified by the dispatcher picks up the other operator in an agency repair vehicle en route to the problem lift station.
When this emergency crew arrives at the lift station, the dispatcher should be notified and given an estimate of when the crew will call back in again. This procedure notifies the dispatcher that the crew has arrived at the lift station and protects the crew in case a serious injury occurs and they are unable to contact the dispatcher.
If the crew doesn't call in again and the dispatcher cannot contact the crew, then rescue operations are started.
During stormy weather, the crew should be very cautious.
Fallen power lines across the chain link fence could cause electrocution to personnel trying to open the gate.
To locate the cause of an alarm, the emergency crew should inspect the station's power supply.
If a lack of power supply to the station is the problem, contact the control center dispatcher by radio to notify the power company to restore power to the station.
Dispatcher should determine estimated time of arrival of power company crew and then notify the field crew.
Since lift stations are essential to a community's welfare, power companies place a high priority on restoring power. The next thing to inspect during a station alarm is whether there is open access to the dry well side of the station.
Measure the atmosphere in the lift station and work areas for sufficient oxygen and the presence of explosive and toxic gases. If during the test of the station atmosphere the gas detection meter indicates an adverse condition, the crew must leave the station dry well and ventilate the dry well area with a portable blower.
Continue to test the atmosphere in the station until the ventilation fan has been running for at least 30 minutes.
Here's a reminder. OSHA requires 16 air changes before entering a confined space, and to do that, varying amounts of time will be required depending on the blower size and space being ventilated. If the station must be entered to correct a serious problem, additional help must be requested.
You will also need a safety harness and self-contained breathing equipment for re-entry to the station under hazardous conditions. All applicable confined space entry procedures must be followed in these situations.
Next, turn your attention to the station wet pit area. Examine this area carefully to make sure that it is not flooded.
Another area to check is the dry well area.
If it's flooded, don't restore power to operating equipment if power is out. If electric motors are flooded and won't start, open main power switches to avoid providing electricity to the area.
If you're not qualified to operate or perform checks on electrical systems, don't do it.
Request help in setting up emergency pumping equipment. Locate and repair the leak to the dry pit. Pump the water out of the dry pit with portable pumps. Conduct electrical megar checks on electrical circuits and motors.
A Mager check will help you determine whether electrical circuits or motors can be operated or need to be repaired.
A Mager is an instrument used to check electrical resistance on motors, feeders, bus bar systems, branch feeder wiring, and grounds.
Next in the station alarm inspection procedure is inspection of the control panel and the power center.
If the dry well area is not flooded and equipment looks normal, in other words, there are no broken pump shafts, no pump shafts rotating backwards, and the valves are closed and seated, then return to the motor control center and power panel.
In some stations, full power can be restored to all operating equipment at one time. In other cases, especially where large pumps are used, full power should be restored one unit at a time. In any case, follow the standard operating procedure for that particular station.
The station book should describe the proper starting sequence for all of the station equipment. Here's a suggested starting sequence. Station lights, station ventilation equipment, start station sump pumps and listen for any unusual noise, station control system, the air compressors, essential station auxiliary system, the water wells and hydraulic system pumps, station last pump to start, station second pump, station lead pump, and all other station systems.
As each piece of equipment is restored to service, it should be checked for proper operation, lubrication, and if appropriate, operating pressures and flow rates.
The station book should indicate the operating ranges of the equipment. Start the smallest pump first, and start pumps in order of increasing capacity. If a pump with a large capacity is started first, the wet well level may fall quickly, and by the time the crew is ready to test run the last pump, the wet well level is too low for automatic operation of the pump.
The pump may be inspected in the manual mode of operation, but this does not guarantee that it will operate in the automatic sequence.
If the wet well is flooded and has inlet gates, the gates should be closed or throttled in order to store wastewater in the gravity portion of the collection system until the wastewater level in the wet well can be restored to normal elevations. The station book should list the procedure for closing the inlet gates and specify the critical time the gates can remain closed before damage will result from flooding.
If the lift station inspections indicate that the wet well levels are fluctuating too much or that the pumps are starting and stopping too frequently, then changes to the pump start and stop cycles need to be made.
Install a continuous flow recorder for several weeks.
Analyze the daily flow cycles and then try to adjust the different pump start and stop cycles so that the pumps can operate as continuously as possible. Before the crew departs the station, they must make sure that it is functioning properly, damaged equipment is isolated, and that the station will operate until repairs are made.
The following tasks should be completed before leaving the station. The station restored to service. All equipment inspected. The station problem and correction recorded in the station book, along with the identification of the crew doing repairs, and the dispatcher contacted to verify that the alarm condition is clear. Complete a report form listing crew members, vehicle and equipment numbers, time dispatched, time of arrival at station, work performed, and time of departure from station.
Secure the station as you leave by locking up. Later, request a review of the cause of the station failure to determine if any action needs to be taken to prevent future failures.
Records are an important part of a lift station operation and maintenance program. They should be filed at the agency's main office.
Filing records.
Gonzo, when we say filing records, that's not exactly what we mean.
Taking the records with you from the lift station to the agency is the only way the records will be useful to supervisors or managers. Frequently, records left in lift stations get lost or misplaced. Active records, those of the current year, should be kept in the office copy of the station book. This procedure keeps all information at one source. Today, some agencies are keeping records on computer disks and using laptop computers to make it easy to update and transport the records.
Periodically, the records from the station book should be removed and placed in the permanent records for the station.
This method keeps the station book at the office from becoming too bulky and keeps only pertinent data in the book for the station's operation and maintenance programs.
The records kept on each lift station should include the costs of operating and maintaining the facility.
By keeping accurate cost records, these costs for operating and maintaining the station provide the information needed to prepare next year's annual budget. Cost data on a lift station may be kept in the office of a supervisor where the supervisor is expected to maintain up-to-date records, or the information may be recorded on forms supplied by the agency's accounting division.
In many cases, the use of a computer can help simplify the entire record-keeping process.
The equipment and preventive maintenance schedule for tasks to be performed on a monthly, quarterly, semi-annual, and annual basis must be properly identified.
When this work has been completed, the operators need to sign the appropriate forms and place them in the station book. The unscheduled report form should show the type of work, why the work was done, and the costs associated with it, labor, material, and equipment.
Drawings need to reflect all modifications made to the station or force main. All drawings and plans must be kept up to date to facilitate future work and to evaluate station performance.
It's especially important to have a written report detailing any unusual conditions or repairs made to the lift station.
These reports should indicate how repairs were made, time required, unusual conditions encountered, special equipment or materials needed, or additional maintenance scheduling required in case the job needs special attention or must be repeated in the future.
The nature of our work is that it is repeated. Often the work we perform has been previously done by someone else. That is why it is imperative that you keep up-to-date records.
Important operational data includes flow records, equipment lapsed time meter readings, chlorination rates, and other operating data that may be required by your agency.
I hope this video has stimulated your thinking regarding the operation and maintenance of wastewater lift stations. Our experience has shown that proper design and maintenance are the key to lift station reliability. Lift stations can effectively operate themselves if properly designed and given the care they need. Gonzo, lift stations are important, aren't they?
Absolutely, they're essential. I mean, without lift stations, skiing would be no fun at all. How else would you get to the top? Of course, lodges are important too. I mean, you need a place where they can put a cast on your leg, you know, when you fall. Not that I've done that, but I've heard.
You heard it first right here. We'll see you next time.